Solving trigonometrical identities equations is probably one of the most difficult things in the further maths course because there are so many steps involved. But one of the things, or a few things to make it easier, are just looking at the few trigonometrical identities that you need to know for this. They're given on the formula sheet. And my first step in approaching this type of question would be to write out those identities on the page so I can see them and see what I'm going to be using. So we've got tan theta is identically equal to sine theta over cos theta, and the other one is sine squared theta plus cos squared theta is identically equal to 1. We do have to be able to rearrange this, of course, or either of them, so that we can use them. If this is true, then it's also true if we minus sine squared theta from both sides, that cos squared theta is identically equal to 1 minus sine squared theta. Of course, it's also worth remembering that sine squared theta is just another way of writing sine theta squared. So those are the same things. This is just a special notation for this instance, only used in trigonometry, whereas sine squared theta means the same thing as sine theta squared. So looking at this first question, I've got to rewrite it in a form involving only one trigonometrical function. This has got two, it's got cos and it's got sine at the moment. Because I've got cos squared theta here, I'm going to replace that with the easiest thing from my identities here. Cos squared theta is the same as 1 minus sine squared theta. So I'm going to replace that bit there and rewrite it as 2 lots of 1 minus sine squared theta plus sine theta minus 1 equals 0. Expand the brackets, 2 minus 2 sine squared theta plus sine theta minus 1 equals 0. Put the number terms together, that gives me minus 2 sine squared theta plus sine theta plus 1 equals 0. The problem here is that I've got a minus 2 in front of my sine squared theta, and because I'm going to need to factorize it later on, I want that to be positive. So in order to make that positive, I'm just going to multiply everything in that expression by minus 1. So 2 sine squared theta minus sine theta, let's change the sign, minus 1, and 0 times minus 1 is still 0 there. So that's my answer to the first part of the question, rewriting in a form that involves only one trigonometrical function. It only involves sine now. That means I can factorize that, and I need to look at that thinking about how I would factorize it if sine theta was written as x, because that's the way I'm used to seeing it. So if I do that, obviously to get 2x squared I've got to have 2x in one bracket and x in the other bracket. I'm looking for two things that multiply to minus 1, and that's got to be plus 1 and minus 1. So the question is, where do I put the minus 1 and where do I put the plus 1? I've got to end up with minus x. So I want minus 2x plus x in the middle, and that's how to factorize that expression there. If I write that now, x is sine theta, so I write that out in terms of sine theta. That's 2 sine theta plus 1 sine theta minus 1 equals 0. So either 2 sine theta plus 1 equals 0, which means that 2 sine theta equals minus 1 and sine theta equals minus a half, or sine theta minus 1 equals 0, so sine theta equals 1. I can use my calculator to look at this result here. Theta equals inverse sine of minus a half, sorry, that's important. Minus a half, sine to the minus 1 of minus a half, which equals minus 30 degrees on my calculator. For the rest of this, I'm just going to sketch a graph because it's going to be important from here, and it's going to be important in all the answers to these questions. The range we're looking at is 0 to 360, so sine theta from 0 to 360 is a full up and down of the curve, going from -1 up to 1, crossing at 0, 180, 360. If I'm looking at sine theta equals 1, there's only one point on the graph where that's true, and that's at 90 degrees. So from this solution I get theta equals 90 degrees. This solution's a bit more complicated. -1/2 gives me -30 degrees. -30 degrees is down here, and that gives me -1/2. Where else gives me -1/2? Well, we've got solutions here and here. Those would both give me -1/2. If I look at the symmetry here, this value here is 30 degrees below 0, so the symmetrical value is going to be 30 degrees above 180. So my solutions here are 180 plus 30 degrees and 360 minus 30 degrees, because everything is the same 360 degrees on. So 360 minus 30. So this solution, 180 plus 30, is 210 degrees. This one is 330 degrees. So all of my solutions I've got now are theta equals 90 degrees, 210 degrees, 330 degrees. And of course, because I've given myself limited space, I've kind of jumbled everything up. That should be written out all in order as I did it, but give yourself more space so that you can see where the solutions are coming from each time, and keep these two branches of solutions separate to make sure that you're getting all of the possible results from your graph for each of these. Here I have sine squared theta plus cos theta plus 1 equals 0. Because I've got the sine squared theta, I want to replace that using the identity that sine squared theta plus cos squared theta equals 1. So sine squared theta equals 1 minus cos squared theta. So that's 1 minus cos squared theta, that's replacing the sine squared theta, plus cos theta plus 1 equals 0. Now I've only got things in terms of cos, so that's 1 minus cos squared theta plus cos theta plus 1 equals 0. Those 1 plus 1, that becomes 2. So minus cos squared theta plus cos theta plus 2 equals 0. Or, in fact, I want to have all of these as, I want a positive value of cos squared theta, so I can times everything by -1. In the last question I just brought everything over to the other side by adding cos squared theta, subtracting cos theta, and minusing 2. It has the same effect if I just multiply everything by -1, so that gives me cos squared theta minus cos theta minus 2 equals 0. I have to factorize this. This is a quadratic in cos theta. So just like with x, it might be easier to see it with x. Just separate this from the previous question. Might be easier to see this with x. That looks like x squared minus x minus 2 equals 0, which we can factorize fairly easily. I'm going to use straight away, I'll do it with x as well. It's either, in terms of x there, then it's x minus 2 plus 1. We need to end up with a minus x in the middle. So minus 2x plus 1x. So in terms of cos theta then, cos theta is our x in this case. That's cos theta minus 2, cos theta plus 1. That tells us that either cos theta equals 2 or cos theta equals -1. If we look at our graph of cos theta, and again I'll just sketch this from 0 to 360, so cos theta starts here, goes down, and 360 is a full period of that graph, going up to the starting point again. we can see that cos theta equals 2 is not a possible solution from this. So that's not going to give us any values at all. That's because the highest value up here is 1 and the lowest value down here is -1. It's impossible to get 2 from cosine of any angle at all. It's never going to give us 2. So we just discard that solution completely and look at this solution. Cos theta equals -1. In this interval, that only happens once, and that's at 180 degrees. So theta equals 180 degrees. If we were looking beyond 360, then of course it would happen again down here, and it also happens at in negative values as well, for negative values, negative angles. But in the range that we've been told to look at, 0 up to 360 degrees, it only happens just the once, at 180 degrees. Next question, very similar thing. I'm going to replace that sine squared theta with cos squared theta minus 1 minus cos squared theta. So again, I'll write that identity underneath. Sine squared theta is identically equal to 1 minus cos squared theta. So I can rewrite this using 1 minus cos squared theta in place of sine squared theta. 2, 1 minus cos squared theta minus cos theta minus 1 equals 0. That gives me 2 minus 2 cos squared theta minus cos theta minus 1 equals 0. And then writing out in the order that I normally would see it, that's minus 2 cos squared theta minus cos theta. Collecting the numbers, 2 minus 1 is plus 1 equals 0. And I'm going to times everything by minus 1 here. That gives me 2 cos squared theta plus cos theta minus 1 equals 0. And if I write that out as in terms of x instead, that's 2x squared plus x minus 1 equals 0. That's just going to make it easier for me to factorize up here. 2x squared means that I've got a 2x and an x at the start of my brackets. Then I'm looking for things that multiply to minus 1. Well, that's got to be plus 1 and minus 1, and I've got to end up with plus x in the middle, so I want that to be a plus 2x minus 1x. So if I write that out now in terms of cos, that's 2 cos theta minus 1 times by cos theta plus 1 equals 0. So either 2 cos theta minus 1 equals 0, 2 cos theta equals 1, or cos theta, or this goes further to cos theta equals a half, and I've got cos theta equals minus 1 from this solution here. So here theta equals cos to the minus 1 of a half, inverse cos of a half. Again, I need to sketch this diagram every time when I'm solving this, because I'm solving it for everywhere from 0 to 360. A half is cos 60 degrees. I can use my calculator for that, or I might know it. Cos 60 degrees gives you 1/2. So that gives me theta equals 60 degrees. And if I look at this graph, 60 degrees is also going to be repeated here. So that's 360. This is 360, 180 in the middle, and 0. If it's 60 degrees from the start, it's going to be 60 degrees back from there, because these are symmetrical. So from this solution I get 60 degrees and 300 degrees. 60 degrees and 300 degrees. From this solution, cos theta equals minus 1. The only solution I'm going to get there is 180 degrees. So my solution overall lists all of these values, not cos theta, just theta itself. Theta equals 60 degrees, 180 degrees, and 300 degrees. Next one, cos squared theta plus sine theta equals 1. I can replace again this cos squared theta with 1 minus sine squared theta. So 1 minus sine squared theta plus sine theta equals 1. Let's get that all on one side, so I'm going to minus 1 from both sides. 1 minus 1, that's 0, minus sine squared theta plus sine theta equals 0. I will times by minus 1 again. Sine squared theta, just being really careful to swap the signs if you do this, swap every single sign in it. Sine theta equals 0. I can then factorize this and take sine theta out of brackets so that I've got two things that multiply to make 0. That means that either sine theta equals 0 or sine theta minus 1 equals 0. So sine theta equals 1. Looking at the graph of sine theta, sine theta equals 0 is here, here, and here. So that gives me the solutions. I'm going to get some others from here in a minute. That gives me 0 degrees, 180 degrees, 360 degrees. Sine theta equals 1 only happens once at 90 degrees. So in fact that's my whole solution there. And this one, order is a bit different, but it's the same kind of problem. Instead of I want to replace the cos squared theta with 1 minus sine squared theta, so I'm going to do that with 1 plus sine theta minus 2 lots of 1 minus sine squared theta equals 0. Expand the brackets, 1 plus sine theta minus 2 times minus sine squared theta is plus 2 sine squared theta equals 0. Writing it out in the expected order, that's 2 sine squared theta plus sine theta. 1 minus 2 is minus 1 equals 0. I've got similar brackets here as I had before. If I just write it out in terms of x, because it's more complicated than the other one we looked at, if I was to factorize that, that would give me two things that multiply to minus 1. That's a plus 1 and a minus 1. And I obviously needed 2x and an x to make 2x squared at the start. So I need to plus 1 where it's going to give me plus 2, so that when I subtract 1 I'll be ending up with plus x in the middle. So if I write that in terms of sine theta, that is 2 sine theta minus 1. Sine theta plus 1 equals 0. So either 2 sine theta minus 1 equals 0, and therefore 2 sine theta equals 1, and sine theta equals a half, or sine theta equals minus 1. So if sine theta equals a half, looking at the graph and using what we know, or using calculators, theta equals inverse sine of a half, which is 30 degrees. 30 degrees appears here and there, the symmetrical place. 30 degrees, 180 minus 30 degrees. That's the other answer that comes in here, because that's 180. Sine theta equals minus 1 happens here, only once in this region, and that's at 270 degrees. So this other solution, theta equals 270 degrees, and again you can get that from your calculator. Sine to the minus 1 of minus 0.5. It would actually give you minus 30 degrees, which is a bit confusing. No, I did the wrong thing then. Inverse sine of minus 1 would give you minus 90 degrees if you type it into your calculator, but that is the same as 270 degrees. It's the same part of the curve. So our final solutions here are theta equals 30 degrees, 150 degrees, and 270 degrees. That's the end of the first question.